Kasianchuk, who will be your presenter today. Peter?
Good morning. My name is Peter Kasianchuk. I'm an instructor with the Educational Products team here in Redlands, California. Joining me today as well is Don Keeney, who is a CAD specialist with the Product Management Group. He's available to answer your questions. I'd like to welcome you all to today's live training seminar. For those of you who are new to the live training seminar experience, there will be 3 question and answer sessions in this presentation. We encourage you to type in your questions early, and if you already have one that you'd like to ask, please enter it now. We're going to cover 3 topic areas today. First, we'll review how CAD interacts with the ArcGIS desktop environment. In our second topic, we'll discuss some issues specific to working with CAD data. And third, we'll review the geoprocessing environment in ArcGIS and how it can relate to CAD data and your workflows. Each of these topic sections will be followed by a software demonstration where I'll show you something of what I've been talking about. We'll come back and review and then have a question and answer session where Don will answer as many of the questions as time allows. In the first topic section, ArcGIS and CAD Data, we'll review the many ways that CAD can be used with ArcGIS, the range of tools and applications available, specific tool sets by license level, supported CAD formats, and a review of some CAD terminology. CAD can be used in a number of ways with ArcGIS, but any of these number of ways will require various geoprocessing tools. Even a simple view to explore the CAD data requires some kind of data translation. You may only need to use one tool once in a while to convert CAD to GIS, or you may be using many tools on a daily basis to support ongoing GIS to CAD conversions. ArcGIS provides you with tools to support all of these different tasks. To begin, ArcGIS contains direct read technology. This has been available with ESRI products since the release of ArcView version 2 almost 10 years ago. Direct read technology creates 2 representations of CAD data in ArcCatalog, ArcToolbox, and ArcMap. These 2 representations are the CAD drawing and the CAD feature data set. As shown here in the catalog tree screenshot, we have one file being shown in 2 different ways. This white icon, the CAD drawing, is a single file. The CAD feature data set is pulling information from this single file and breaking it down into component geometries, which include polylines, polygons, point, multi-patch, which are 3-dimensional objects, and annotation. In addition, we have a number of CAD-based geoprocessing tools, and I'll discuss these in a little bit more detail shortly. Additional CAD tools can be found in other products. The Data Interoperability extension gives you the opportunity to import 70 different data formats. 4 of these data formats are CAD. So this Data Interoperability extension is not CAD specific, but does give you functionality to use it. In addition, this extension product exposes a fully customizable data interoperability workbench, which allows you to specifically configure how you want to use your data. The ArcSDE has a CAD client module, which allows you to embed CAD functionalities at the database level. And ESRI business partners and others provide third-party solutions for utility industries and others, which create these third-party hybrid CAD and GIS systems, some of which may embed GIS functionality into existing CAD systems. We won't be discussing these systems, ArcSDE, or the Data Interoperability extension any further in this presentation. This seminar will focus on ArcGIS desktop tools. Shown here is a breakdown of some of the tools available by license. As you can see by the names here, some are very CAD specific, but many tools aren't. I should point out here that CAD in its native data sources can be used as inputs for many geoprocessing tools. For example, feature class to feature class or append. You can use a CAD drawing file or feature data set as input for these tools. However, there are some CAD-specific geoprocessing tools available with ArcView and ArcEditor, and also ArcInfo. Import from CAD and the Import CAD Annotation tool are two examples. I'll be showing you how to use these in upcoming software demonstrations. ArcInfo provides you with some additional CAD geoprocessing tools. One that is not CAD-specific is the Select tool. There is, however, in the conversion tool set of the ArcInfo license, a CAD to CAD tool set here, which includes 4 tools: Set CAD Alias, Export to CAD, Create CADX Data, and Add CAD Fields. I'll discuss these in a little bit more detail in the second topic section. All of the tools that I've just described support many different CAD data formats. The CAD data formats that are supported are these: the MicroStation DGN file and a number of different sub formats of these. So DGN 5 through 8, 95, SE, J, and V8 DGN files are all supported. Similarly, with the AutoCAD formats DWG and DXF, back to R12, R2000, and R2004. So as you can see in the catalog tree screenshot that we have on this slide, each of these files, DXF, DGN, and DWG, are all treated the same using the direct read technology. So we have an individual drawing file and that feature data set. In addition, if you have the ArcInfo license, you can convert the older Intergraph formats IGDS and IGES into coverages. Here we have a brief review of some of the terms that I will be using in this presentation that you may encounter elsewhere, and these are specific to CAD data. For example, you might encounter entities called blocks or cells or tags. The blocks or cells are grouped entities or elements that may behave as a single object in CAD. XData and MSLinks refer to ways or methods in CAD to extend attributes from the default schema. You may discover or encounter something called an XRef. This is an external reference, a way that a drawing file may reference or be referenced by another drawing file. So you might embed these within each other. Page space and model space are similar to layout view and display view for those of you who are familiar with ArcMap. Bring this to your attention that ArcGIS doesn't recognize objects contained in CAD page space. So if you have something in your CAD page space, a north arrow or a scale bar, for example, ArcGIS won't recognize that. This is something you'd need to consider if you're converting drawings from one format into GIS. So this brief overview of how CAD can work with GIS brings us to our first software demonstration. I want to introduce you to the data that we'll be using for the upcoming demonstrations and show you a little bit about how this is used in ArcGIS. In this first demo, I'm going to show you how some of the differences between the CAD data set and the CAD feature class, and then I'm going to show you how easy it is to convert CAD data into the GIS feature classes using simple tools and methods. Here we have a CAD drawing. You can see that it's represented by one icon in the catalog tree, and it also is displayed with some default symbologies. This is kind of a direct read-only functionality. You can see that if I right-click on this layer and grab the properties, these are also read-only. We'll discuss spatial reference in the next section. Here under the General tab, we can see that the CAD drawing is organized into a number of different layers. This is quite helpful, but there are quite a number of them, and some of these codes might not have any explicit meaning. You can also see that there are some invisible layers. We can't change any of the properties on this tab. This is read-only. I can also move to the CAD feature data set and expand on this and see that we've got these 5 default geometries. Annotation is grabbing the text information from that CAD drawing. You can see that some of the properties are different there. Multipatch refers to 3-dimensional objects. We don't have any information in that layer. Some points. The polygons, as you can see, are referring to polygons as structured in CAD and may not correspond to what you're used to in GIS. These are arrowheads and point features. Most of the information in this CAD file is contained within the polyline layer. So let's move to ArcMap and see some of the differences there from these two similar data sets. First, I'm going to add that polyline information that we were just looking at. And you can see that the first thing that I can do is change the symbology. This is different than what I would see in a drawing file where the symbology is all fixed based on the defaults that we saw in our catalog. So I'll add that drawing file, and you can see that the symbology is the same, but I can't change it. I'm going to remove this file for the time being and manipulate this polyline feature class first. One of the things that you can do with the polyline is treat it just like any other layer. CAD data sources have very similar behavior to a generic layer file with the addition of these two tabs, drawing layers and transformations. We'll talk about the transformations tab here on the right in the next software demo. As you can see, I've inherited some default drawing characteristics with this CAD file, but I want to turn them all off. I've done some investigation and discovered that PL stands for property lines. I want to extract this information out of that polyline and do something else with it. In this case, I'm going to click OK, and you can see that the only polyline information being drawn is now that property line layer. I want to create a GIS feature class out of this information only. I can right-click on the layer, go down to Data on this context menu, and export this data. The default data format is a shapefile. I want to save this as a geodatabase feature class. In this case, I'm going to save it as such. Oops, here we go. There we go. Export output. Click OK. And now I'm going to add that geodatabase feature class as a new layer. Turn off the CAD data, and you can see that on the fly, I converted this CAD into a geodatabase feature class. As simple as that. Couple of button clicks and done. Now, in this particular case, I had a CAD data set that had its information organized in layers. You might not always have that possibility. In some cases, you might have all your CAD information stored on one generic layer, and you need to use another technique to extract information of interest. In this case, I can use an attribute of the CAD data. In this case, I happen to know there's something here called color, which may correspond to a value I may or may not know, but I'm going to use an attribute to select some information and export that. So select by attributes. In this case, make sure that I've got the polyline layer. Color, come on now, equals a number of unique values. I'll just pull out all the objects that equal color 1. And you can see that that's now extracted a subset as well. And using the same technique, I could export this data as a new GIS data layer. A third technique that I want to show you involves an editing session. I'm going to add a geodatabase feature class. In this case, I have an existing lines layer. And I want to take some information of interest from this CAD layer. In this case, again, I'm going to use the property lines. Click OK. And I want to add these polyline features from the CAD layer directly to my lines feature class. I'm going to start an edit session. And you can see that now my target layer is that lines feature class. That's all I have available. I can't edit CAD in its native format. However, I can use this edit tool to select the CAD features. And you can see that now the copy button has been enabled on my standard toolbar. I'm going to copy these features. I'm going to turn off this CAD layer to show you how this works. I can now paste those features into my lines layer. By clearing my selected features, you can see that I've simply copied what was in the CAD polyline and added it into my lines feature class. Stop editing, save my edits, and that's another way that you can convert CAD to GIS using very simple methods and not even going into Arc Toolbox. However, this is considered geoprocessing. So in summary, for this first demo, I've just shown you 3 ways to convert CAD to GIS without using any special tools or methods. I first exported data using a CAD layer. I exported data from CAD to GIS using selected attributes. And then I used an edit session to cut and paste selected features. So let's review what we've just gone through in this first topic section. We briefly reviewed some common tasks that you might consider when using CAD data with GIS. Showed you ArcGIS CAD tools broken down by license and other products, told you about the supported CAD data formats, and a brief review of some common CAD terms. Hopefully that's generated a number of questions. I'm going to turn it over to Don Keeney to answer some of them for you. Don?
Thanks, Peter. We'll go ahead and get through some of these. Michael from Bethlehem. Can the projection from CAD drawings via AutoCAD Map or other products be imported to ArcGIS? Well, in the second section, we're going to be talking more about spatial reference, but a short answer would be the coordinates that are used in AutoCAD Map or in the CAD program are very useful in the defining of the spatial reference. We're going to need a little bit more information for ArcGIS to identify that coordinate system in the projection file, and Peter will be discussing that a little bit later. Bridget from Fredericksburg, can you bring dimensions from CAD directly into ArcGIS? Currently, the support for dimensions is not in the core tools, but would be available in the data interoperability extension. Something that we're probably not covering in this, or we're not covering in this class. Another question from Paramount from Jean. If a DXF file is 3D, how would you then import those features into ArcGIS for something like ArcScene or ArcGlobe? The CAD feature classes do support a three-dimensional feature class called the multi-patch, and so three-dimensional objects would be displayed through that feature class. Sean from Topeka asks, we need our CAD users to provide us with data that is useful for ArcGIS. Is there a way that CAD users can add fields and have them link back to preserve attributes that otherwise might exist only as CAD annotation? There are a couple of standard methods to encode information that are usable. For example, in MicroStation, it'd probably be best to use an MS link for an external table. You might consider in AutoCAD using the AutoCAD handle to link to an external table. Make use of things like blocks with attributes and tags. Well, go ahead and send it back over to you there, Peter.
Thanks, Don, and thanks for putting in your questions. Please keep them coming. We have 2 more Q&A sessions. In the previous section, we showed you various ways that CAD can be used with ArcGIS and introduced you to a couple of the tools. In this section, we need to discuss some additional issues you'll need to consider. We've already had one question about georeferencing, so we're going to talk about that. Going to review CAD data structures and what you need to know to use tools appropriately. And lastly, the special case of dealing with CAD annotation. Where you have CAD files that have some coordinates associated with them, you may or may not have these coordinates referenced to real-world units. Origin points are a CAD parameter that default when you open a new drawing to 0, 0, 0, which represent a starting point in the X, Y, and Z axes. Many times you can create a CAD file without having to change that origin point. And in addition, you may receive, as a GIS user, CAD files that don't have real-world coordinates associated with them either. So you might have CAD feature coordinates that start at 0, 0, 0 and may correspond to inches, for example. You need to have some mechanism for ArcGIS to understand or translate what those original CAD coordinates are in real georeferenced space. ArcGIS uses something called a world file to store the parameters to transform those CAD coordinates into georeferenced coordinates. This world file is an external file that ArcGIS uses to store these coordinate values, and it can be based on a 1-point transformation or a 2-point transformation. I'll show you the differences between these two in the upcoming software demonstration. However, CAD data may be projected. That is to say, the origin point may correspond to real-world coordinates, and the units being used by that CAD drawing are also real-world coordinates. However, CAD data doesn't have any way to identify this coordinate system. It's up to you as a GIS user to go in, examine the CAD data, and make an educated guess on what the coordinate values might mean. If your CAD data is projected, you need to create a .prj file in ArcCatalog. The key point to be made, and I'll make it here and again in the software demo, is that you need to store that new PRJ file with the same name as the CAD drawing file. That will tell ArcGIS what the projection system is, and you can then have the CAD data line up with your existing GIS data. So to restate this, the relationship between these two things is that where you have CAD data that is not georeferenced, you need a world file to transform that data. Where you have a CAD source that is projected, all you need to do is identify what that projection system is using a .prj file. Another topic we need to discuss is the nature of CAD schema. CAD drawings store information in a single large table-like file. That's the DWG drawing file. All the information is simply stored in this one file where the schema is not exposed. There's not a way in ArcGIS or in CAD for that matter to really take a look at the nuts and bolts of how that data is structured. In fact, what we're looking here on this screenshot is a result of the direct read technology, where we've taken that CAD drawing file and tried to expose some of that schema based on ArcGIS. In addition to not being exposed, there may be other structures or schema relationships embedded in CAD that you may need to know about. For example, we discussed external references, things such as MS links or XData, which may contain additional attributes that you need to use. Further, there might be special internal structures within that CAD schema, blocks, cells, tags, etc. In addition to schema, CAD attributes are different than what you might expect in GIS. CAD attributes are primarily concerned with storing symbology. And from that symbology, you as a user or a reader need to infer what that symbology means. What we're showing you here on this screenshot is that we have a single entity called the pipe, and information about that pipe is stored within two different entities in CAD schema. First of which is something called entity type line, and it's storing some drawing information about that linear feature. The color is red, and it's stored on a particular layer. In addition, there is an entity type inside of CAD schema called text, which stores additional information about that pipe and may be displaying something like this 8-inch text value. GIS attributes, on the other hand, store the meaning associated with that single element. And from that meaning, for example, feature, functions, or behavior, we infer what that feature is supposed to be doing, but the GIS attributes don't store anything about how that needs to be drawn. This difference between how CAD and GIS store their feature attributes is very important for using many tools and for leveraging this information between translations between systems. Understanding CAD schema is important when you want to use the import from CAD tool and the export to CAD tool. Most of the time, the direct read technology that we've just described will give you all the information you're going to need from a CAD source. But from time to time, you may require more control over how you want that represented in the geodatabase, or you may have some CAD data that's structured in a special way that you need to manipulate in a customized manner. The import from CAD tool, available with the ArcView and ArcEditor licenses as well as ArcInfo, creates something called a staging geodatabase. The staging geodatabase exposes the normalized CAD table structure. So what we've got here, I've taken that Plat 677 drawing file and created a CAD staging geodatabase where it's got these 4 default geometric feature classes plus all these tables, some of which may or may not be populated. For example, MS Link is only going to be useful for microstation formats. Export to CAD also requires that you have some understanding of CAD schema, because this is not a direct conversion of GIS schema to CAD. You will need to perform some pre-processing before you can use this tool to create useful CAD schema. In this case, add CAD fields, create CAD XData, this is a new schematic structure for CAD, or convert or set CAD aliases for existing GIS columns. Once you've done some pre-processing using these tools, you can then use the Export to CAD tool to create useful CAD schema in any of the supported CAD data formats that we mentioned earlier. Pulling all these ideas together, you need to consider which attributes you need to use and how you might leverage the tools between exchanges from GIS to CAD and CAD to GIS. For example, how will you preserve information, GIS information, that CAD doesn't use? In this case, preserving GIS attributes in CAD formats, you might use that X data, for example. Another way that you might preserve GIS information is to encode CAD symbol properties using your GIS attributes. Going in the other direction, you'll need to know something about CAD data standards. For example, what does color number 1 mean from my first example? You may want to translate CAD properties into GIS attributes. Some understanding of attributes and CAD schema is useful for helping tell the story about CAD annotation. The CAD annotation feature class that you might be familiar with in ArcGIS is a result of the direct read technology. Generally, CAD text is stored in independent layers, but direct read pulls that text information and creates an annotation class out of it. As well, geodatabase annotation feature classes have very specific schema. For those of you who have created a CAD or a GIS annotation layer from scratch, you'll see that there's default schema. In order to manage this translation from CAD layers to geodatabase schema, use the Import CAD Annotation tool, again available with ArcView and ArcEditor. Before you use this tool, you'll need to do some pre-processing. For example, you may need to add additional symbol sets or fonts from that CAD file that aren't supported by default. Also, you'll need to take a look at this CAD annotation to identify symbol levels and text settings before conversion. And I'll show you how this works in the upcoming software demonstration, which is now. So the first thing that I'm going to do in this demo is show you a manual way to georeference CAD data. In this case, I have a parcels layer here, which is a GIS feature class. And I also have the CAD drawing layers added. In this case, I've got that drawing layer, which isn't being displayed. The reason for that is that if I zoom out to the full extent of both data sets, you can see that this might be something that many of you are familiar with. My GIS layer in georeference space is way over here on the far right. And way over here on the far left, I've got this colorful smear, which actually refers to my CAD drawing file. I'm going to zoom into that layer. And you can see that a couple of things are going on. First of all, the north arrow is pointing to the left. So in order to get this CAD layer to correctly line up with my existing GIS information, I'm going to have to rotate it to some degree. And it also looks like it might need to scale. How am I going to do this? Well, the first thing that I want to do is find coordinate values from features that are in common. I happen to have a line going across the north here, this red line, which corresponds to another line in the GIS layer. I can zoom in a little bit to show you that this is actually some very useful survey information. I'm going to use the Identify button to grab some coordinate information from this line itself. So by clicking on that line, I see that there's a start point and an end point and coordinate values associated with them. I have a fairly high degree of precision in here. I would manually or perhaps type into a text file these coordinates here to store them for an eventual two-point transformation. That's what I'm leading to with this technique. But this may happen to a number of you where you've got some CAD data and you just need to start somewhere. Let's zoom to my GIS layer and zoom in on the corresponding parcel. You can see that the shape is familiar, but it's been rotated almost 90 degrees and the size is a little bit different. I need to discover the coordinate values for the same points on this. How would I do that? Here, I would start editing, select this feature, double click, and expose the sketch vertices. In this case, I'm going to hover over this vertex and click on Properties, and then scroll down until I find that highlighted vertex, quite a few of them here, and record the values here. So this point that's highlighted with that white dot corresponds to that first one that I showed you in the CAD layer. Now, I'm not going to take the trouble to do all the typing. I don't think you'd find that very interesting to watch. I've done this ahead of time and recorded these values, but this is a technique that you might consider when you need to orient or transform your CAD data. So I'm going to move back to my CAD source, examine the properties, and look at the Transformations tab. You can see that I've transposed the from coordinates of that line into these boxes here and recorded the same coordinates in the GIS layer in this box. I've now decided to transform this by this 2-point transformation. So I've got 2 pairs of points. I also have rotate, scale, and translate. This refers to that 1-point transformation that I was talking about, where I've got 1 point here in the CAD layer, and the 2-point is the GIS layer, where I would have, the software, in this case, populated the angle and scale. But if I only had the 1 point to 1 point, I would need to figure these out by myself. That's why I use this 2-point coordinate transformation. You will have noticed that I already had this typed in. Why didn't the CAD layer automatically line up? Because in order for this to work, you need to enable transformations. So I'm going to turn that on, click OK, and you can see now that the CAD layer lines up with my GIS layer. And I can hear the oohs and ahs over the internet now. One way that I might want to preserve this is by creating a layer file. Currently, these coordinate values are only stored as a property of the map document. This isn't going to be permanent in the database or associated with the CAD layer. So I can save this as a layer file with a .lyr extension. We'll take a look at that shortly. If I now move, okay, so let's turn these off. I'm now going to move to ArcCatalog and show you that if I refresh my data layer here, you can see that I've got that CAD drawing layer, and you can see that it's been rotated and it's in its correct orientation. However, the CAD data source hasn't changed. This is still in its original orientation, and if I right-click on this particular property, you can see that there's no information associated with it. That tells you that the 2-point transformation that I just did in ArcMap is only a property of ArcMap. I want to make this more permanent. Here I've got something called the text file with the WLD extension on it. I'm going to open that up and show you that I've got the same coordinate values that I used for my 2-point transformation stored in a text file. The structure and syntax for this is also available in ArcGIS Desktop Help, but I've just created this text file with the .txt extension. By removing that txt extension, ArcGIS and ArcCatalog will now recognize the fact that it's a world file, and if I go back to my CAD data source, you can see that it's now been rotated. I'm going to refresh this and show you that the same thing has occurred with my feature data set. Now move back to ArcMap. If I turn on that CAD layer and look at the properties, you'll see that if I move to the world file, I can then associate that on a permanent basis. Okay, I've just shown you, the last thing that I want to do is make sure that this is permanent. Go back to ArcCatalog. Now that I've associated the world file, I also want to define the projection system. I'm going to go to a known source. I know now that this lines up with a state plane. The key point to be made here is that you need to save this as a file with the same name as the CAD data. So in this case, make sure I spell it correctly, Plat677, click Save, and if I refresh my folder, you can see that this Plat677.prj file is now associated with this information. All right, I've just shown you 2 ways that you can save transformation or georeferencing information. The last thing that I want to show you is how to convert annotation information. Let's add that again. Is how to convert CAD annotation into geodatabase annotation. Let's see if this lines up. There we go. Should turn that on. We've got 2 ways of representing textual information with CAD. The first is by the default drawing parameters. In this case, you'll notice that we've got a number of specific text and font elements in different colors. That's the drawing native properties. If we look at the information as annotation layer, you can see that this has automatically been translated into a generic Arial font with a black style. I want to change that before I convert this to geodatabase annotation. So I can go to the annotation layer and change some of these font properties. This is some of the investigation that you should do before translating. See what these different symbol numbers refer to. So with layer 0, I'm very quickly going to change some basic parameters just to show you how this works. You can see that they're all a generic font type. That might not be what you want to preserve. The point that I'm making here is that you can change them as part of the CAD drawing layer before conversion. Let's zoom out to this layer and open Arc Toolbox. And again, this is a tool that's available with the Arc View level. Go to Conversion Tools, to Geodatabase, import CAD annotation. The input features are going to be this annotation layer. You can see that you can add a number of CAD annotation layers. I'm simply going to accept the defaults of the reference scale. I'm going to create annotation classes from levels. I'll show you what that means shortly. Match symbols from first input is referred to when you have multiple annotation inputs. I'm going to click OK. And you'll see that what happens is that the annotation properties are going to be saved to or stored in the resulting annotation layer. Simply add the annotation layer. And you can see that what's happened is two things. First of all, the properties that I set in the CAD annotation have been preserved in my geodatabase annotation. And in addition, the layer properties from which the CAD text was drawn have been preserved. So I now have some additional control over annotation subclasses. So I just showed you how to georeference a CAD data layer and two ways to store that as a layer file and as a world file. And then I showed you how to change annotation default settings from CAD before converting these to geodatabase annotation features. A quick review of this second topic, how to georeference CAD, a discussion on how CAD schema and feature attributes are different in CAD than they are in GIS, how to use or the uses you can use import from CAD and export to CAD, and a discussion on CAD annotation. Hopefully that's generated some additional questions. Don?
Yes, thanks, Peter. Peter from Redstone Arsenal actually has two questions. The first is ArcGIS 9.0 now compatible with V8 MicroStation? The answer to that is yes. We also support direct read of AutoCAD 2000 and the versions of each of the software before then. His second question is, if the CAD data has labels, how can I use the labels to attribute the feature classes for points, lines, and polygons as I migrate to ArcGIS? That question maybe has a couple different answers. One, you could use the annotation as an annotation feature class like Peter just demonstrated. You could also associate pieces of text with other objects using spatial tools that he'll also demonstrate in the last demonstration. Tools like near or features to polygon, which will allow you to associate text, objects, or blocks with other pieces of geometry. The other another way to answer the question is if you're using block attributes or MicroStation tags as labels, those would automatically appear in the feature classes for points, lines, and polygons that they're associated with. Kava from Fairfax asks, what file format should I ask for CAD operators to export from AutoCAD and MicroStation so that it would be easier for me to read this into ArcGIS? Later on, Peter's going to show you some more resources that might be available. There's a white paper that delves more into the subject of how to create ArcGIS compatible CAD data. But a short answer to that question would be that for the geometry, really, the direct read is all about the fact that you read the native format. There's no export of that geometry that is needed. For external attributes that may be stored in a database table, there are ways to directly read that information as well by traveling the MS links on MicroStation data, or there may be a piece of X data that links information to an external file. So anything that you can associate, a CAD property with an external table would be useful. Another question from Linda in Paso Robles. How are polyline widths treated in ArcGIS? The polyline widths would be treated as an attribute in the database. If you want to use that to drive some symbology, that would be possible for resymbology. I think we have time for one more question. It's kind of a follow-up question to the one earlier about dimensions. If you explode or drop CAD dimensions in a CAD file, would ArcGIS be able to read the individual lines and pieces of text? And the answer to that question would be yes. That would be one way to pull in dimension information and make it viewable in ArcGIS. So back to you, Peter.
Thanks a lot, Don, and thanks for your questions. So far, we've shown you a number of tools and techniques, sort of one at a time. Let's put it all together in this last section and take a look at a couple of approaches that you could use to automate CAD into GIS and review some of the things that you'd need to consider when designing geoprocessing and workflows. Let's go back to the beginning. What do you do with CAD? For many of you, this may be a one-time CAD to GIS data conversion, and simply using one tool at a time might be all you need. On the other hand, some of you might need to use multiple CAD data sources to populate a new geodatabase from scratch, or to populate existing geodatabase information from multiple CAD imports. Perhaps you have a number of CAD-based map sheets that need to be stitched together into a single thematic layer. Third option might be that you have a regular ongoing data exchange between CAD and GIS systems. As we mentioned off the beginning, ArcGIS provides you with tools and methods to support all of these different workflows. What we're looking at here with this screenshot is something that looks a little bit like Model Builder. Where you build complex models or scripts, ArcGIS gives you this ability to embed documentation and help files to describe your workflow. But before you get to that, some of the things that you might need to consider before designing these workflows: where you're going from GIS to CAD, some of the things that you could consider is to manipulate your GIS data to be more CAD friendly. That's really what the ArcInfo 2 CAD toolbox is all about. But you can use other techniques such as basic schema edits in ArcCatalog, or functionality such as the field calculator to populate GIS symbology fields with attributes. As we discussed in some of the earlier questions Don just answered, you might want to export GIS feature attributes to block or X data structures. This is something that you might consider using the Staging Geodatabase to help you with. Where possible, standardize your symbology to conform to other CAD standards. You might want to have access to CAD symbology lookup tables, or if you're using the Export to CAD tool, you have the opportunity to use something called a CAD seed file. And a seed file is essentially blank CAD schema, and this is something that you may create yourself or your CAD expert can help you with. Going in the other direction, where you're dealing with bringing CAD into GIS, perhaps the single most important thing that your CAD users can do is georeference the CAD data. Instead of having a 0, 0, 0 origin point, turn it into a real-world coordinate. In addition, organize similar features by thematic or logical layers. Perhaps all of the information is simply on one drawing layer. Break it out a little bit if you can. Document the CAD attribute codes. And in general, analyze your CAD data structures before you convert them. That's really what the direct read technology is very helpful for. I would also take this slide as an opportunity to give you an additional tip. Use ArcCatalog to create metadata files for your CAD data sources. ArcCatalog is excellent for maintaining metadata and will create these XML files for CAD data as well. Now that you've taken a look at your workflows and considered some of the things in pre-processing and geoprocessing that you need to do, you have a couple of different ways that you can store and manage this. The title of this seminar includes the word geoprocessing, which is a very broad term. Essentially, any spatial data manipulation can be considered a geoprocess. We've already shown you how the tool works and some basic editing techniques. Shown on this slide are two additional techniques that you might consider. The Model Builder gives you a graphic interface which allows you to create repeatable groups of tools and methods. This can be quite involved, but saves you a lot of time from going to a one-at-a-time kind of approach. Scripts do essentially the same thing, but in a textual environment, and ArcGIS is commonly using Python scripting for this. Scripts give you enhanced functionality, such as running processes at remote times. We have additional educational materials which go into considerably more detail on the geoprocessing framework and how to use Model Builder and scripting. in this next software demonstration, I'm primarily concerned with showing you how easy it is to do this with CAD. So let's get to that, shall we? In this case, I'm going to be using the same demo, information, but with a couple of different scenarios. In this case, I've got that line information that I was looking at and the polyline CAD data source, which has been georeferenced. And this is something that I should point out both here and later on, is that models that we're using and tools that we're using here assume that your CAD data is georeferenced. So let's open Arc Toolbox. And for those of you who are new to ArcGIS, this one of the things that you need to know about is that if you want to create a model, it needs to be in a custom toolbox. So I've got something here called CAD Translation Samples, which is one of mine. And I'm going to create a new model, which opens up this blank canvas. Very easy to use. The first thing that I want to do is extract some information of interest from this CAD polyline. So I'm going to use this Select tool and simply drag that tool into my Model Builder canvas. I'm going to right-click on that tool and open up its parameters and set some input parameters here. So what I want to use is Polyline CAD Features. You can see that the output feature class has automatically been created as a temporary file. I also have the opportunity to build an expression. In this case, I want to use that layer information that I know about to pull out easement information from that CAD polyline. In this case, I happen to have a logical layer called easement, and that's my expression. So what this means is that this tool is now going to pull out those polylines that correspond to easement on that layer. So I now got one model element. The next thing that I want to do with this output is append it to my existing lines geodatabase feature class. So I'll go to the general tools here and click on the append tool, drag that onto my canvas, and set some parameters for this append tool. In this case, the input features are going to be the result set of my first tool, and the output features are going to be the existing lines layer. This schema type is looking for schema match. I know that it's not going to match, so I don't want anything rejected. In that case, I'll click No Test, click OK, and I now have a model that I can use that strings together two different tools and automates a process. I'm going to run this model inside of the Model Builder environment, and as it runs through, it'll be fairly quick. You'll see that these elements are going to change their symbology as the model runs. You can see that the tools turn red, and that went through very quickly. It wasn't particularly detailed or heavy-duty processing, but I really wanted to demonstrate how easy it is to create a model to automate some CAD functionality. Has anything changed? Well, let's turn off the CAD polyline, and you can see that that information for the easements has automatically been added to my lines feature class without opening an edit session. That was one example of a very simple use of the Model Builder technology. The next thing that I want to do is explore this CAD Translation Samples toolbox just a little bit. On the last slide of today's demo, we'll be showing you where you can download all of these tools. These have been created and are maintained by Don Keeney, who you've been listening to over the Q&A sessions, and provide a very rich set of functionalities. Here we've got some CAD translation tools. I'm not going to open all of them because some of them are actually fairly large. I will show you one shortly, but I wanted to give you an idea of some of the models and scripts that are available here. Some export to CAD tools, export points to CAD text. Some of you are interested in how can I leverage my CAD text into something other than annotation. Take a look at these export to CAD tools. What I want to show you is that I've taken one of Don's generic tools, and a number of these are generic, and switched them to my own purposes. Here I've got something called the LTS custom model. By opening it, you can see that it's actually entitled Generic Model to Create Polygons from Lines and Point Feature Attributes. What does this actually mean? It means I'm going to take CAD lines, create GIS polygons, and populate the attributes from CAD points. What I've done here is taken the generic model and actually filled in some of my own parameters for my own data sets so that I can use it for my particular data. So we took a look at it there. One of the things that I want to show you here is that there's actually a tool description, which tells you what this tool is going to do, plus some additional help. Most of the tools in this sample toolbox have this information associated with them. Where you create your own, you have the opportunity to do this yourself. The other thing that I want to show you is that you can also run a model as a tool from our toolbox. So the first demo, I ran it inside of Model Builder. In this case, I'm going to run this as a tool. Come on now. As you can see, I've populated some of the inputs already. And what this tells you is that my input boundary lines are that polyline CAD data source. I want to extract the property lines, which I know close. And I want to associate those property lines with some annotation information pulled in from the lot numbers layer. Just to make sure that all these polygons close, I've defined a fairly narrow cluster tolerance. And I'm now going to put this into the output geodatabase called poly test, save, and run this tool. So what's going on here is that I'm actually pulling out lines on the fly, creating polygons out of them, and adding additional attribute information based on the CAD annotation. So there we go. I'll turn off some of the other information and show you that what I've got here is those polygons that were created, plus labeled information that was brought in from the annotation. In this case, it happens to be the parcel numbers. Oops, turn that label features on. And that's one use of a model that is available for you for download right now. So that's all I wanted to show you in this software demonstration, was briefly how to construct a model from scratch, but also some of what's available to you now with a little bit more complexity. Hopefully that's generated some additional questions, but first let's take a brief review of what we just talked about in this last topic section. Some additional discussion of how you might use CAD data with ArcGIS, and depending on what you're using it for, which way you're going to be going, some things you need to consider when going from GIS to CAD and CAD to GIS, and how easy it is to automate CAD interoperability using Model Builder. Don, do we have any additional questions?
Yes, we do, and I'll try to get to as many as I can in the time. We have Russell from Bend is asking, what is the best way to convert polylines into polygons once loaded into the geodatabase? Well, Peter had just shown one method, a simple method of creating polygons out of CAD points and lines. And when you have high-quality CAD data, that's probably the easiest and best way to do it, is using the geoprocessing tool features to polygons. If your CAD data needs a little bit of cleanup, or you're not sure about its quality, you might consider using the polyline information from the CAD file within ArcMap in an editing session and applying the different topology tools and cleanup tools to more precisely clean up any errors that might be in the CAD file geometry. Rob from Glenwood Springs asks, when I try to import CAD annotation from CAD, sometimes all the annotation is not preserved. Does this mean that some annotation is on the CAD page or maybe in Paperspace? Well, the answer to that question is most likely if you view a CAD drawing layer and you see a bunch of annotation, but when you look in the annotation feature class, it's not there. Most likely that information is included in a block attribute. And currently that information is not included in the annotation feature class. The best way to get at that information then would be to use the import from CAD tool and look for the attributes in the point feature class, and also there's a table called text properties, and you'll be able to access that information there. In a future release, that information would also be included in the annotation feature class. Fernando from Camp Murray asks, is there a white paper discussing georeferencing CAD using GIS? There are actually a couple of white papers that Peter's going to be showing you or referencing in the final slide that discuss the topic. Gary from Santa Fe asks, can we import data in a reference file, or does import only use the main file? Well, the import from CAD tool also sees a reference file and includes it as its reference point. And so you can see that there is indeed a reference file, and one could use that information to build a script to travel it. By default, however, it will just read the main file, but that could be automated So if you need to add additional reference files, you can just use them with the direct read individually, or when you're using the import from CAD tool to include them all when you do the import. Lastly, Floyd from Austin asks, how did you create the world file, or where did you get it? The world file is simply a text file, and the syntax for that file, as Peter mentioned earlier, is found in the help file. So it would simply be a set of coordinate pairs that would show them, would allow you to define that transformation or a single point with a rotation and angle. And again, that information on the syntax is there. So let's take it back to Peter.
Thanks a lot, Don, and thanks for your questions. It looks like we're about out of time at this point. Some of you have asked for additional information. Now, the first thing that I'll point you to is Arc scripts, available through support.esri.com and a couple of other places as well. It's quite well cross-referenced. By typing in at Arc scripts the keyword or search word CAD, you should be able to locate the toolbox named a CAD Geoprocessing Sample Toolbox for ArcGIS 9, written by Don and maintained and updated. And I would encourage you to do that today. There's lots of excellent samples in there. Some additional information available at a higher level through Arc News, written by David McGuire, improving CAD to GIS interoperability. And again, going to support.esri.com, browsing for technical articles using the keyword CAD will give you at least these four: how to transform coordinate locations, as you can see, CAD translation, and a number of others. Lots of good information in the technical articles. And lastly, if you haven't already done so, I would encourage you to go to the ArcGIS desktop help files, and simply typing in that keyword CAD under index, you'll discover that there's a lot of excellent information on how to work with CAD there as well. On behalf of ESRI, I'd like to thank you all for attending this seminar.